In this video, we're going to show a fun, interesting, at the same time puzzling fact. 0.9999 forever nines equals to 1. We're going to show why. But first, let's look at what does this mean exactly. So we have infinite number of nines. How about there's only one 9? Then the value is 0.9. And this is 0.1 away from 1. If we have two 9s, that's 0.99, then this number is 0.01 away from 1. In other words, 0.99, 1 minus this is equal to 0.01. 1 minus 0.9 equals 0.1. So this number represents the distance of the 0.99 away from 1. How about you have three 9s? 0.999. What's the difference away from 1? It's 1 minus 0.999 equals 0.001. And clearly, if you have n 9s, so 0.999, if you have n 9s, then the distance away from 1 is 1 minus 0.999 n 9s, and that will be equals 0.0001, and here you'll have n minus 1 zeros, or also if you write as scientific value, this will be 10 to the minus n, 10 to the minus n. Right? So as the number of 9s increase, the distance away from 1 is getting smaller and smaller. It actually goes to 0. Now, this can be a proof about 0.9999 infinite 9s will be equals 1, but this is going to using some very advanced math, especially the idea of limit. In this video, we're going to show a rudimentary proof of 0.999 forever 9 equals 1. And we're also going to show that the technique used here can also be applied to other problems. So let's show that. To do that, let's first denote this number 0.999 forever 9 as an x. Okay? The value of this 0.99 forever 9 is x. And the technique here, or the trick here, is multiply 10 on both sides. So 10 times x is going to equal 10 times 0.999 forever 9s. And then this equals, remember that when you multiply 10, really means that you move the decimal point to the right once. So this equals 9.999 forever 9s. And we're going to write as 9 plus 0.9999 forever 9, right? Do you recognize something here? Because they are infinite 9s, this number is same as x, right? Removing one 9 from infinite number of 9s still result in infinite number of 9s. So this whole thing equals 9 plus x. Okay, let me write down the furthest left thing, 10x, and the further right thing is 9 plus x, which means 9x equals 9, which means x equals 1. Aha! We just proved that x equals 1. So here the technique here is uses this fact about there are infinite number of 9s. So if you remove one 9, there are still infinite number of 9s. This is kind of a self-similar property, if you will. By removing 9, it still have the whole thing there. Okay? And we're going to apply the same technique about if you have infinite number of something, removing one term does not really matter. The problem, second problem, goes like this. Evaluate square root 6 plus square root 6 plus square root 6 plus. Just keep doing this, okay? Infinite such numbers. Again, they were square root. So the number is basically you have square root 6 plus square root 6 plus square root 6 plus. It just keep doing this. 6 plus and go on, okay? What is this number? And we're going to be using a technique very similar to the above. Let's denote the value of that thing is x. So x equals square root 6 plus square root 6 plus square root 6 plus, go on, square root, go on. Now I'm going to square both sides. X squared going to equal 6 plus square root 6 plus square root 6 plus square root 6, go on. Okay, do you recognize this term? By removing 1 6 out of the square root, the inside thing is still a and x. Agree with that? So this whole thing equals 6 plus x. Again, we have x squared equals 6 plus x, or x squared minus x minus 6 equals 0. Now for this, clearly it has two roots. X, actually we can factor it. X minus 3 times x minus 2, x plus 2 equals 0. So the two roots are x equals 3 or x equals minus 2. But now realize this square root thing is going to be a positive number, then this solution is not going to be a valid solution. So in here, this term, or the final value of square root 6 plus square root 6 equals 3, which is by no means an obvious result. But here we go. We have this technique. Because they are infinite terms, you can use this technique to get the value. I hope you enjoyed it.